Welcome to CS3308 Information Retrieval. This is the Unit 2 lecture part 1. During this lecture, we're going to talk about something that really isn't addressed in our textbook, but I thought it was very important for you to understand because it really kind of helps us to understand how a information retrieval system is actually constructed and how it works. Now we're going to talk a little bit about a technology or a capability known as MapReduce. Now, MapReduce is something that came out of the big companies, the Googles and the Yahoos, etc., that developed search technology, because one of the things that they had the need to be able to do is to process enormous inverted indexes. They had to build these very large inverted indexes, and they needed to do so efficiently. So what they did is they came up with a very specialized capability that allows them to do that. Now, we are not actually, and I mentioned this in the previous lecture, but as far as the assignments in this class, we're not going to actually build an information retrieval system in the way that we normally do it. And one of the reasons why is because it's really a lot of complexity in that. So what we are going to do is we're going to use a simple database as a way of keeping track of or building the data within our dictionary and our postings file. And the reason we're going to do that is because it eliminates the need for us to kind of build it separately and sort and merge and do all these kinds of functionality. But in a large scale information retrieval system, we'd want to be able to do that because, quite frankly, as these collections of documents get large, it takes a long time to process. So the only way I'm going to do that efficiently is by parallelizing it. And the technology that we use to do that is called MapReduce. Now there's an implementation of it. I'm quite sure you all have heard of it. It's called Hadoop. But again, the Hadoop is just an open source implementation of this MapReduce concept that really originally came out of the information retrieval discipline, and in particular was a way of processing huge numbers of documents in search solutions. Now, let's kind of talk a little bit about what the problem is and what we're trying to do. So we know that in our information retrieval system, we're going to have a index, and we're going to create these inverted indexes. And the way that we do that is that I have a large collection of documents, and the first thing that I do is I select a document and I want to tokenize it, or I want to take all of the words out of it or terms that are in there out. I want to extract them, and we talked a little bit about the fact that the way that I do that is I look for things that are surrounded by white space. For example, the word tokenize in here is surrounded by a white space. It has a space in front of it and it has a space behind it, so I know that it kind of is a word. I can also use the same process to extract the word extract and to get the word words, and then I can see that these are punctuation, and I kind of strip that punctuation off. But essentially, once I've got all those terms, basically I want to go add them to a dictionary. I want to count the number of occurrences that I'm finding, because that becomes an important thing, and we'll learn that later in the course, how I use this counting of occurrences both within a document as well as across the collection, and it helps me to do ranking. I need to sort them, right? So I have to get them in sorted order, because in order for me to search these efficiently, I need to have them in some sort of a sorted fashion so that I can quickly find them. And these things are both memory and time consuming, particularly when I look at it at an internet scale, because at internet scale I might be dealing with millions and or billions with a B of documents. So when you look at what Google's doing on a daily basis, they're literally scanning or processing, indexing billions of documents a day with petabytes, somewhere in the neighborhood of 20,000 petabytes of data. It's just incredible numbers. So I need to have a methodology that really does this very efficiently and very quickly. So there is this need for a much more efficient solution, simply because of the scale at which we're operating at. Now, what exactly is it that we're doing? Well, if you think about it, I have this collection. So let's say that this is a document right here, right? And it has 3 different terms. So what I'm basically doing is I'm extracting those terms from the document, and I want to count how many occurrences that there are. I have another document here, right? And it also has 3 different terms in it, and I'm counting them. So basically the output that I have here is I want to be able to extract the terms. I want to be able to count the terms and then summarize that data. In this particular case, I have one instance of Bob, one instance of Ron, two instances of the word see, one instance of the word spot, and so on and so forth. Now you can imagine doing this across millions of documents with potentially millions of different terms. So you can see where the problem comes in. But essentially we can map this into kind of a map reduce type of a process using a technology such as Hadoop. So what I might say is I want to use one process to run this document and maybe a whole series of documents behind it, and perhaps I have a second process that that is excuse me, that is processing this document and perhaps other documents beyond it. So essentially what I'm doing is I have two different distinct processes. They're actually going to go through and count the terms. And we're going to kind of refer to this as the map portion of the process. Now, once this is done, I have an output from this one, I have an output from this one, and that's where the reducer comes in. So what the reducer does is it basically takes all of the output from the map process and it combines them and reduces them into a single data set. So essentially this would be the output from the mapping process, right? I've done my counting, I've looked at the number of terms that exist in the document that I'm running, which is this top one, and I've also done that for the bottom document. Then what I'm doing in the next step of the process is I'm going through the reduce portion of it, which says I'm going to take all of these terms in the documents, the output documents, that I've produced, and I'm going to combine them and summarize them. This is kind of the merging the data and perhaps resorting that data. Okay? Which is essentially what happens within MapReduce, or what Google uses in their own proprietary implementation of it, or of course the open source version, which is called Hadoop. And essentially have some amount of input, and we can think of, if we think about our corpus, think of this as perhaps even entire collections of documents here, right? And I have these mapper processes that are going to go through, and as they go through it, they're going to extract each of the terms and they're going to count those terms. Now what's going to happen is it's going to export that in a what we call a key value pair, and perhaps the key value in this particular case is going to be a term. So a term, and for every term, a count, right? So every term and the number of instances of that term that were counted. And then what happens is all of these outputs, so we might take all this documents as input, do that counting to find all of the terms and the quantities of those terms, write that into a document, and then those documents then flow into the reducing process, right? Where essentially what I'm going to do is I'm going to try to merge each of the output documents together, sort them, and then make sure that I'm recounting those terms that happen to be like between the different documents. So hopefully this kind of gives you an idea of this process, mapping portion of it, reducing portion of it. And essentially in an information retrieval system, that's what is typically done. The input of this might be a web page or a whole series of web page that gets fed into one of these mapper processes. It's going to extract all the tokens or all of the terms from it. It's going to do the basic counting within that document. It's going to build its own dictionary and posting lists. And when it's done with the allocated amount of work that it has, it's going to hand those dictionary files and posting lists over to the reducer process, and the reducer process is going to take that dictionary, that posting file, along with all the other dictionary and posting files that were produced by all of the other mapper processes, and try to merge them together and sort the terms. So essentially what I wind up having is one dictionary file, right, where everything in it is in sorted order, and to that it has a series of summarized postings. Okay, building out my entire information retrieval system. Now, one of the things that's unique about Hadoop and the MapReduce framework that Google has made to do this is that it's designed around this concept of a distributed file system. Now, essentially what that means is that I might have multiple processes. And in fact, what we normally are doing is we're spreading this workload across multiple physical servers. And to make sure that they all have access to the same data, essentially what we do is we create a DFS, or a distributed file system. So that's a file system where the files on it are visible to every single one of the computers in that cluster. Now, in the case of Google, there may be thousands or even tens of thousands of servers that exist in this cluster. So it parallelizes the work, and because it's so parallelized, it allows us to do vast amounts of this kind of indexing relatively quickly. Just kind of look at specifically a model of Hadoop. And again, very similar in what Google does. Again, Hadoop is kind of just an open source implementation that's currently maintained by the Apache project, but essentially same basic idea. I have my HDFS, or my distributed file system, or Hadoop, which stands for Hadoop Distributed File System, and essentially it says all of these different servers, because these blue boxes represent different servers, have a process on them, and I'm basically taking all of the data that I have, the corpus perhaps, and I'm going to segment it up into chunks, right? And to each of these servers, I'm going to hand one of these chunks. It's going to go through that map process, and as an output of it, okay, as an output of that, it's going to produce its own dictionary file and its own posting list. And I then move those files, all of them, because they're considerably smaller. This is kind of the source data. I have all the stuff in here. I'm summarizing it through the mapping process by just getting the appropriate terms and the number of those terms. I'm just counting, right? So now I just have terms and counts, and then I use the merging process to kind of reassemble, put them back together, and to do the sorting on them. So essentially I'm doing merge and sort and updating of the data as I merge it in the reduced process. So hopefully this has given you a little bit of an insight into Hadoop and how it works, and the fact that this is how we would typically be using the kind of technology that we would normally be using to build our inverted index, simply because I can spread it across many different servers, and it allows me to build a dictionary in each one and then merge those dictionaries and then do the sorting. And you can see where there's a lot of complexity in this, and that's one of the reasons why we have opted not to do that in this class. So for our actual assignments, we're just going to use a database, because it kind of does the sorting for us. But keep in mind, it's pretty limited. So you'll even notice this with the corpus that we have. It's going to take a while to do, simply because I don't have the efficiency and the ability to spread it across multiple systems the way that I would in a typical implementation that we use something such as Hadoop.